So thanks for being here. This is actually not so much a research talk as a talk about research vision. So the vision is about how we could go towards zero carbon computing and why we need sustainable computing. And so just a bit of context, which you probably already know. So we really need to cut a lot of greenhouse gas emissions to keep warming below 1.5 degrees. And we must do that now. We can't really wait another 10 or 20 years. And also, we can't do this if we believe that everything can keep on growing unlimited. And this is particularly true for computing. We have been treating computing as if it's an infinite resource, and that's partly the fault of Moore's law, because basically every year and a half, everything has become twice as fast and twice as big. And so we've been, on the one hand, been relying on that, and on the other hand, been enticed to always buy new stuff. And even though the next generation may have been more power efficient, the growth in demand cannot really offset that. And so also making these devices is hugely, leads to a huge amount of greenhouse gases. So we need what I call frugal computing. And what it really means is that we should start treating computational resources as finite and precious, and we only use them when we need them and as frugally as possible. So that's very much like Anna has been saying. So we're really on the same page there. But as computing scientists, we need to ensure that every computing task has the lowest possible energy consumption. And we also very much need to look at the lifetimes of our computing devices. So we must really end this planned obsolescence and this tendency to buy new devices very quickly. And why is that actually? So if we want to meet 1.5 degrees, we will have to reduce emissions from 55 to 23 gigatons per year. And electricity is currently about 10 gigatons of that 55. So renewables are 30% of that 10 or more gigatons by 2040. Now they are much less, right? But it's just saying even by 2040, they will only be 30%. And so we can definitely not rely on renewables to power all our devices with green electricity. They won't be there. So the only thing we can do is consume less energy if we want to avoid catastrophic warming. And we should avoid catastrophic warming, right? If we just look at computing then, by 2040, projections differ a little bit, but basically there's some consensus that energy consumption from the devices will be 5 gigatons of CO2 equivalent. And if you take the production of the devices also into account, it will be more like 10 gigatons. And that's about half of the total budget for the planet for all of emissions. So that's totally unsustainable, right? We can't say purely for computing, we'll take half of that 23 gigatons that is necessary to keep our warming in check. And that's what this diagram says, basically. Right now, in 2020, computing is this little red bar at the top. And if we do nothing, it will end up in 2040 as a much larger part. And this is assuming that we've managed to reduce all the other things to meet our targets. So if we don't, if we reduce everything else and we forget computing, we are still in trouble. So we really must go towards zero carbon computing. So we have 20 years to do that. We need to change the way we compute to meet the targets. We must reduce the carbon costs of both production and operation of computing. And I mean, this is not just a technological challenge, just as with everything else, with not eating meat and so on. We need change in business models, we need change in incentives, we need change in consumer attitudes. So this is really something that requires a much more holistic approach to tackle the problem. But on the other hand, I'm a computing scientist, so I want to see what we can do as computing scientists. So I have a little vision for computing science. And it's basically like this. So assuming that we can't rely on the next generation, so no new gadgets, no new toys, we should make the best of what we have. And by being better at computing science, we could actually make those devices that we have now last a lot longer, and they would even perform better if only we took the effort to do that. And so every time we have a new advance in computing science, we could actually make our current devices easier to use and so on, without any increase in energy consumption. Obviously, they don't last really forever. So meanwhile, we need to develop new technologies, and they should be a lot greener and also designed to last a lot longer. So then you have a cycle going, because the next cycle will be even greener and last even longer, and so on, and you get the picture. So in the end, we will have devices that practically last forever and hardly use any energy, and that's a very good place to be. And that's my vision. So thank you very much. And so I wrote a paper about this, which you can see online. It has a lot more detail.